Today's video is about estimating roots. So let's scroll down here to the academic active vocabulary and we're going to do some review. Match each term with its definition by drawing a line to connect the two. Monomial. That's an algebra word, so we're not going to worry about that one too much. Let's go down here to perfect square. A perfect square is a number that is a square of an integer, such as 4, 9, 16, or 25. Scientific notation, we're not really going to worry about that one too much yet. We'll come back to it in a later lesson. So we can kind of cross those two out. We're not going to use them. A square root is one of the two equal factors of a number. So that one matches right there. You could kind of figure out the other two if you wanted to. But again, we're not coming back, or we will come back to those at a later time. For right now, you just need to know the difference between a perfect square and a square root. Alright, let's go down here, label the diagram with the correct terms. The base, okay, is the A, it's the big number. So base and B, they both start with, base and big number both start with B. So this is the base, and the exponent is the little number up here, so this is the exponent. And that just should be a little bit of vocabulary review for you. All right, moving over to the continued page. This is the new stuff. It says complete the following steps to estimate square root of 75 to the nearest whole number. So if you look back at that list of the perfect squares between 1 and 400, you'll notice that 75 is not on there. But it falls between, the square root of 75 falls between two whole number square roots. So the greatest perfect square that is less than 75 is 64. Right? 64 is equal to 8 squared. Okay? The least perfect square that is greater than 75, so if you're looking on the other side of 75, is going to be 81. So this one is 8 squared, this one is 9 squared. So since 75 is closer to, well, let's think about it, 64 to 75, that's 11 away. 75 to 81, they're a distance of 6 away, so it's closer to 81 than 64. The nearest whole number estimate of 75 is going to be somewhere between, it's going to be somewhere between 8 and 9. So let's draw a little bit of a picture for this so you can kind of see it on a number line. Okay, here is 64, here is 81, and 75 is about right here. So if you think about, these are the perfect squares down here, right? 81 and 64, these are perfect squares. And we think about their square roots, we can write them up top. So the square root of 64 is 8, the square root of 81 is 9, the square root of 75 is going to be somewhere between 8 and 9, but closer to 9 than to 8 because 75 is closer to 81. So these two up here are your square roots. So I'm really hoping that picture helps you understand that. Okay, so let's look at number 1. Number 1 is the square root of 114. So the least perfect square that's less than 114 is 100. And we know that 100 is equal to 10 squared. And then the next one that's above 114 is 121, and that's going to be 11 squared. So this square root of 114 is going to be somewhere between 10 and 11, but 114, that's 14 away from 100, and it's 7 away from 121. It's going to be closest to 11 because 114 is closer to 121 than it is to 100. All right, 17. So if you think about the closest perfect square that's less than 17, that's going to be 16, which we know is 4 squared. And then above it is 25, which we know is 5 squared. So square root of 17 is going to be somewhere between 4 and 5. but it's definitely closer. 17 is closer to 16 than it is to 25, so the square root is going to be closer to 4. All right, 42. So the closest square root that's less than 42 is 36, which we know is 6 squared. And then above it is 49, which we know is 7 squared. So if we think about how far these are away, they're going to be 6 away, and it's 7 away from 49. So this is going to be somewhere between 6 and 7, but closer to 6. And last but not least, number 4, 135. So we know 135 is somewhere between 121 and 144, so that's 11 squared and 12 squared. So this is somewhere between 11 and 12. 135, it's 14 away here, and it's 9 away here, so it's going to be closer to 12. Order these from least to greatest. All right, so we have 4, we have 8, we have square root of 22, and we have square root of 53. So if we think about the square root of 22, okay, that gives us 16 and 25, which are 4 and 5 squared. So square root of 22 is going to be somewhere between those two. It's 8 away from 16, no, sorry, 6 away from 16, and 3 away from 25. So this is going to be approximately 5. So we can write a little 5 under there, a little bit less than 5. All right, square root of 53. Square root of 53. So if we think about 53, that's somewhere between 49 and 64. So that's 7 squared and 8 squared. So this is going to be, let's see, it is 4 away from 49 and 11 away from 64. So it's going to be a little bit more than 7. So if we put these in the right order from least to greatest, the least is going to be 4, and then we're going to have square root of 22 because that was pretty close to 5. And we're going to have square root of 53 because that's pretty close to 7, and then we're going to have 8. All right, helping you remember, in your own words, describe how to estimate the square root of a number that's not a perfect square. So the first thing you need to do is to identify the two closest perfect squares. Step 2 is to find the square roots of these two perfect squares. Okay, and step 3 is to determine the closer square root. All right, hopefully that makes sense. If you have any questions, let me know, and have a happy afternoon.